All right, 26 and 27 we're going to do together because it's asking us to draw the LUMO of it, of a system, which is the lowest unoccupied molecular orbital, and the HOMO is the highest occupied molecular orbital. All right, and both of these are for 1,3,5 hexatriene, which looks something like that. All right, to draw our orbitals, the two that it needs, I need to draw all of the orbitals that are possible on this structure. Now this hexatriene, since each one of these carbons has got a p orbital in there, we have a 6p orbital pi system. So I'm going to draw 6p orbitals to represent the pi orbitals, and I'm going to draw 6 sets of these because those 6p orbitals will go together, add up, and make 6 pi orbital systems. Got 2 more of these. And each of these is a pi. Since we have an even number, the 3 lowest orbitals are bonding orbitals and the 3 highest are anti-bonding orbitals. And lowest orbital, everything's in phase with each other. There are no nodes, so I'm going to shade in the top of those p orbitals and call that how it looks. The next orbital will have a single node. And as we go up, we'll just add another node. So the next one will have 2 nodes. And when I get to that node line, I just start shading the other side of the p orbital. This next one has 3 nodes. I'll end up putting them like that. Then we have 4 nodes. And the top one has 5 nodes, one between each one of these p orbitals. So these fully alternate. All right, our electrons in those pi orbitals drawn on that 1,3 hexatriene is how we're going to figure out there are 6 electrons in this pi system, and we're just going to put them in our orbitals until we run out of electrons, and that shows they're all in bonding orbitals. All right, that tells us the lowest unoccupied molecular orbital looks something like that with 3 nodes in it, and the highest occupied molecular orbital looks like that with 2 nodes. And we get that simply because there's electrons there, so that's the highest occupied orbital, and this is the lowest unoccupied molecular orbital.